Welcome to integration by parts. Again, this is a part of your integration review from Calc 2. So recall our product rule for differentiation said that if we want to take the derivative of a u of x times v of x, that we can do the derivative of u times v plus u times the derivative of v, which I'm going to just shorthand as u prime v plus uv prime. So if we translate this into integration, what we then get is that u times v should be an antiderivative of, so u times v plus c should be equal to the integral of u prime v plus uv prime dx. And we can then split that up. So we have u times v plus c is equal to the integral of u prime v dx plus the integral of u v prime dx. And then rearranging this, we therefore get that if we do uv minus the integral of u prime v dx, but that'll sort of absorb the c into it. This should be equal to the integral of uv prime dx. So if we can sort of rearrange our function so that it's a function multiplied by a derivative, then we can use integration by parts to solve. Usually what I do is I set this up as I put u and then what I call dv, which is v prime times dx. So here's u and v prime times dx. And then if we take the derivative of this, we get our u prime. And if we take the integral here, we get v. And then the formula is just that we multiply these and then we subtract this integral. So I usually use integration by parts just via this sort of little table as opposed to writing out the formula. So if I want to find the integral of x e to the x dx, I'm going to need to pick one part of that to be what we take the derivative of, and one part where we take the integral. So x, taking the derivative of the function gets simpler, whereas if we take the integral, it gets more complicated. E to the x, taking the derivative, taking the integral, it just stays the same. So it doesn't get more complicated either way. So what I'm going to do here is pick u equals x and dv to be e to the x dx. And the reason I did this is because this gets simpler with differentiation. So if I set up my little table, here's my u and dv. I have x e to the x dx. I'm going to take the derivative going down. Let me switch colors there. So going down, I'm going to take the derivative. And on dv going down, I'm going to take the integral. I'm now looking at 1 when I take the derivative and just e to the x as I take the integral. And then I'm going to multiply these together and then subtract this integral. So what we have is that the integral of x e to the x dx is equal to x times e to the x minus the integral of 1 times e to the x dx. And we wind up simply getting x e to the x minus e to the x plus c. And next up, let's go ahead and do integral of e to the x cosine of x dx. So e to the x is easy to take the integral and the derivative. Cosine of x is easy to take the integral of the derivative, but it's maybe a little easier to keep track of the sign if we use it as our derivative. So let's go ahead and set cosine of x to be our u. And e to the x to be our dv. Taking the derivative, going down on the left and integrating on the right. On the left, we have negative sine of x. And on the right, we just have e to the x. And then we're going to multiply on the diagonal and subtract the integral of the product here. So we have the integral of e to the x cosine of x dx is equal to e to the x cosine x. And then we will subtract the integral of negative e to the x sine of x dx. Once again, it's not an integral, I know. I'm going to just quickly rewrite this as e to the x cosine x plus the integral of e to the x sine x. So once again, I'm going to use integration by parts. So for this one, let's go ahead and once again set u equal to our trig function. So u will be our sine of x. dv will do our e to the x. Taking the derivative down the left, we are looking at cosine of x. Integrating on the right, we are looking at e to the x. And then we are going to multiply on the diagonal and subtract the integral. So if we rewrite what we had previously, we have the integral of e to the x cosine of x dx is equal to e to the x cosine of x plus, then this new thing we just found, we multiply on the diagonal, we have e to the x sine of x. And then we will subtract the integral of e to the x cosine of x dx. Now, since I didn't have a subtraction or number multiplying out front, I can just rewrite this right side as e to the x cosine of x plus e to the x sine of x minus integral of e to the x cosine of x dx. As you could see, we could keep cycling through integration by parts, but at this point, notice that these are like terms. So we can go ahead and add that integral of e to the x cosine of x dx to both sides. And we are now looking at two copies of the integral of e to the x cosine of x dx is equal to e to the x cosine of x. I'm going to actually factor out my e to the x, so e to the x times cosine of x plus sine of x. And then we can divide by 2, and then we should throw in our plus c. So we have e to the x cosine of x dx, the integral of that is equal to 1/2 e to the x times in parentheses cosine of x plus sine of x, and then plus c.